This story begins with a glow, unlike any we create with our modern tools. It doesn't come from a bulb, a screen, or even a distant satellite. Instead, it emerges from something far older, something alive. This light drifts through forests and fields, flickering softly in the darkness. Fireflies have illuminated human imagination for centuries, their glow etched into our stories and memories. But behind that gentle golden flash lies a secret, one so efficient it humbles our brightest inventions. What if the key to better lighting wasn't hidden in a lab but already perfected by nature? As cities struggle with energy waste and light pollution, a team of scientists turned to an ancient insect for answers. What they discovered could redefine how we produce and use light in the future. And it all starts with a tiny, luminous beetle. Fireflies are nature's most efficient light sources, floating through the air like living embers. But they are more than just magical. They are masterful engineers of light. These small beetles produce their glow through a process called bioluminescence. Inside their abdomens, a chemical reaction converts energy directly into visible light. What makes this extraordinary isn't just the light itself, but how efficiently it's made. Fireflies convert nearly 100% of their chemical energy into light, a feat no man-made bulb has ever matched. Incandescent bulbs waste over 90% of their energy as heat, and even LEDs lose much of theirs to internal reflections. Yet fireflies perfected this process millions of years ago. They flash to attract mates, warn predators, and communicate in silent bursts of brilliance, and they do it without wasting a single drop of energy. Ancient cultures recognized their glow long before modern science. In a Chinese fable, a boy collected fireflies in a silk bag to study through the night. Their soft light was his only lamp, proving nature's ingenuity. This wasn't just folklore exaggerating nature's wonders. It was nature quietly outperforming human invention. Today, that same flicker holds more than just romantic charm. Scientists are studying not just what fireflies are, but how they shine so efficiently. In doing so, they've uncovered clues that could transform our entire approach to artificial light. To understand why this matters, we must first look at how modern LEDs work. We often take light for granted, flip a switch, and it's there. But behind every LED bulb is a carefully orchestrated dance of electrons. LEDs, or light-emitting diodes, operate through a process called electroluminescence. When an electrical current passes through a semiconductor, it excites electrons. As these electrons relax, they release energy in the form of photons, the light we see. Unlike traditional bulbs that burn filaments or rely on gases, LEDs are solid-state devices. They're constructed by layering ultra-thin sheets of specialized materials, typically gallium compounds. These materials are doped with atoms to create regions of positive and negative charge, forming a junction. It's at this junction where light is born. This design makes LEDs far more efficient in theory than incandescent bulbs. They don't waste energy heating a filament, and they're compact, durable, and long-lasting. Yet despite these advantages, something crucial is still missing. While LEDs generate light internally, not all of it escapes into the world. Some photons become trapped, bouncing around inside the semiconductor layers. Others are absorbed back into the material as heat. This means that despite their reputation for efficiency, LEDs often shine far less brightly than they should. To understand why, we must look deeper, not just at how LEDs produce light, but how they lose it. At first glance, LEDs seem like the perfect light source, compact, efficient, and cool to the touch. But hidden inside these devices is a flaw that quietly limits their potential. The issue isn't how they create light, but how much of that light never escapes. This problem is known as light extraction efficiency. Imagine a room filled with light, but only a few tiny windows to let it out. That's what happens inside an LED. Photons are generated in abundance, but many of them bounce around inside the semiconductor layers. Instead of shining outward, they reflect, scatter, or are absorbed back as heat. Why does this happen? The answer lies in the sharp contrast between the dense materials inside the LED and the air outside. At these boundaries, light often hits at angles too steep to pass through. Instead, it reflects internally, trapped like a hall of mirrors. This phenomenon is called total internal reflection. Even the best LEDs may emit only 40% of the light they generate. Some perform far worse, meaning energy is wasted, not in creation, but in escape. To solve this, we need more than new materials. We need a new surface design. And nature has already provided the perfect blueprint. To address the LED's light-trapping problem, scientists turned to an unlikely source: fireflies. Specifically, they studied the surface of the firefly's lantern, the organ that produces its glow. What they found was surprising. It wasn't smooth, polished, or symmetrical. Instead, it was chaotic, irregular, covered in microscopic ridges and jagged textures. And that, it turns out, was the key. These tiny structures don't generate light. They release it. When photons inside the firefly's body reach the outer cuticle, they face the same challenge as those in an LED. They must escape into the air without being reflected back. But fireflies have evolved a brilliant solution. Their outer shell is covered in uneven, tilted surfaces that scatter light in all directions. Instead of bouncing back, more light finds a path outward. This asymmetry disrupts total internal reflection. It introduces randomness, variations in angle and depth that increase the odds of escape. The result is a brighter, more visible glow without any extra energy expenditure. Modern LEDs sometimes use textured surfaces, but not like this. The firefly's surface isn't just rough, it's intentionally irregular. Nature didn't design it for beauty, but for maximum output. And now, for the first time, researchers are recreating that same brilliance in artificial light sources with stunning results. The brilliance of the firefly's lantern lies in something deceptively simple: disorder. Not chaos in a messy sense, but a purposeful lack of symmetry. Its jagged, uneven surfaces scatter light at unpredictable angles, giving each photon a better chance to escape. This randomness, it turns out, is exactly what LED technology has been missing. In standard LEDs, flat surfaces and sharp material boundaries trap photons. When light hits these boundaries at steep angles, it reflects inward instead of shining out. This is known as total internal reflection, one of the main reasons LEDs waste so much light. But asymmetrical surfaces break this trap. They scatter light in all directions, offering more exit paths. Think of it like trying to roll a ball out of a box. On a flat surface, it bounces back, but on a rough, uneven surface, it can find its way out through countless small angles. By mimicking these random textures down to the microscopic scale, engineers can disrupt the photon traps inside LEDs. The surface stops acting like a mirror and becomes more like a funnel, guiding light outward. It's not just about brightness, it's about letting energy do what it was meant to do: be seen. Once scientists understood how fireflies avoided light loss, they set out to replicate it. The solution wasn't new materials, just new shapes. Researchers created surfaces that mimicked firefly textures. One method added a jagged overlay to existing LEDs. This wasn't just cosmetic. These ridges scattered trapped photons outward. Another group went further, modifying the LED's core structure. By cutting the sapphire substrate at an angle, they created a tilted surface like the fireflies. The results were dramatic, far better light extraction. No exotic compounds, no bulky redesign, just geometry. This is biomimicry at its finest, not blindly copying nature, but understanding its logic and applying it to our tools. Fireflies evolved their glow over millions of years. Engineers replicated it in just a few. The results were record-breaking. Firefly-inspired surfaces delivered stunning improvements. One research group saw a 55% boost in light output using an asymmetrical overlay on standard LEDs. No core changes, just a smarter surface. The real breakthrough came from angled cut sapphire substrates, mimicking firefly structures. These reached 90% light extraction efficiency, a new record. Most LEDs emit less than half their produced light. Reaching 90% means brighter output, less energy loss, and lower heat. This wasn't just theoretical, the researchers patented the design. It was approved in 2020, proving its viability for real-world use. Even better, it's scalable. The angled cuts can be made using existing tools, making mass production possible. For years, we've tried new materials to improve LEDs, but fireflies taught us something simpler: shape matters. Letting light out isn't about force, it's about flow. The implications of this breakthrough extend far beyond brighter bulbs. More efficient LEDs sound ideal, less energy, more light. But every advancement carries risks, including unintended consequences like light pollution. Ironically, fireflies, the very inspiration for this innovation, are suffering from our growing brightness. The problem isn't the technology itself, but how we use it. Brighter LEDs can reduce energy consumption if we use them wisely, but if we flood every space with excessive light, we undo the gains. Efficiency must be balanced with responsibility. Better lights should mean fewer fixtures, smarter controls, and thoughtful placement, not unchecked expansion. Fireflies didn't over-illuminate, their glow was timed, gentle, and purposeful. That's the real lesson here. We're not just replicating a glow, we're being reminded to listen. Progress isn't about maximizing brightness at all costs. It's about knowing when enough is enough. We often imagine innovation as something new, synthetic, born in a lab, but sometimes it's ancient. Sometimes it floats on wings through the dusk, blinking softly. The firefly didn't just inspire a better light, it reminded us that efficiency doesn't mean complexity. It means harmony. As we race towards smarter cities and cleaner energy, we do well to look backward as often as forward. Nature's designs hold answers we've only begun to understand. So the next time a bulb flickers on, remember the insect that lit the way first. If this story sparked something in you, there's more light to uncover. The journey of innovation isn't just about moving forward, it's about observing, learning, and adapting. Fireflies have illuminated our nights for millennia. Now, they illuminate our path to a brighter, more sustainable future. Their glow is more than a biological marvel, it's a beacon of possibility. And as we harness their secrets, we honor the wisdom of nature itself. The brilliance of fireflies lies not just in their light, but in their lesson. Efficiency, simplicity, and purpose, these are the true hallmarks of progress. And sometimes the brightest ideas come from the humblest sources. So let's look to nature, not just for inspiration, but for guidance. The future of light isn't just about what we create, it's about what we preserve. And in that balance, we find true innovation. The firefly's glow is a reminder that the best solutions are often the simplest, and sometimes the answers we seek are already shining in the dark. All we have to do is pay attention. The story of fireflies and LEDs is just beginning. As we refine our technology, we must also refine our approach. Brighter doesn't always mean better, smarter does. And in that wisdom, we find the path forward. The firefly's light is a gift, one we're only now learning to fully appreciate. And as we do, we light the way not just for ourselves, but for generations to come. The glow of the future may very well be shaped by the lessons of the past, and in that light we find hope, innovation, and the promise of a brighter tomorrow. So let's move forward with curiosity, with respect, and with the knowledge that nature's wisdom is our greatest guide. The firefly's flicker is more than a signal, it's a symbol of what's possible when we look beyond our labs and into the world around us. And in that light, we see not just the future, but the beauty of the present. The journey continues and the light grows brighter. But this time, it's not just our doing, it's nature's too. And together we shine.